So today we are talking about how to calculate equilibrium problems using an ICE table. So I have an example problem here. In order to show you how to do this, at 25 degrees Celsius, K equals 0.090 for the reaction. H2O plus Cl2O becomes 2HOCl. You need to calculate all the concentrations for the species at equilibrium. And you're starting with 1 mole of pure HOCl being placed in a 2-liter flask. So, the first thing that we need to do is we need to figure out what is the concentration of HOCl2. Excuse me. What is the concentration of HOCl? So, they give us that it's 1 mole and it's in a 2-liter flask. So we can figure out the concentration simply by taking 1 mole, alright, and dividing it by the thing it's placed in, which is 2 liters, and that's going to equal 0.5. And this is molar, so that's moles per liter. Now, this is our initial concentration. That's what we want. So next thing we need to figure out is we need to figure out what our K equation is. I already created it up for you, so I'm just going to show you. But remember, K equation is equal to the products over the reactants. K equals products, which is our lovely HOCl here. And notice it is squared. That's because it is squared. It has a 2 there in the equation. Right? So it is squared when it is in the K equation, and it is squared when it is in the because it has a 2 there. Down below we have both of our reactants times by each other. So that's our K equation. So go ahead and write that down. That is right where it should be. Next thing we need to do, let's start on our ICE table. I already set it up over here for you over on the left. So let's start with our initial concentrations. Initial. Well, we have nothing for H2O. We got nothing for Cl2O. But we did already figure out what the concentration of the HOCl was. That was 0.5 molar. So what's our change? Well, we don't know yet. So we're just going to put X. So we create X right there. We're going to gain some X. Same thing, the molar equivalent for both H2O and Cl2 are the same, so we're also going to create the exact same amount, so that's also X. Now, everything that we create, we have to get from over here. So, for every mole that we create on the reactant side, we have a mole coming from the product side. So the first thing we're going to write down is, well, we have a mole being created, and we have another mole being created, so we're actually creating 2 moles right there. And I got that because there's that lovely 2 there. Alright? So for every 2 moles of this that is disappearing, 2 moles of this are being created. And that's being taken away. So our change for what we have is right here. At equilibrium, we're going to have X for H2O. At equilibrium, we're going to have X for Cl2O. And at equilibrium for our initial that we put in there, it's going to be 0.5 minus 2X. Is everybody with me so far? So we can then take these numbers that we just found, X, X, and 0.5 minus 2X, and we can plug them into our K equation that we found earlier. So I'm just going to take it. K, which we know, is equal to 0.5 minus 2x, and all of that, don't forget, is squared. On the bottom, well, we just had x times it by x. So that's our equation. Now we need to simplify it. The first thing I'm going to do is I'm going to FOIL this top part right there because it's really confusing right there. So I'm going to just go bring k down. K is equal to, if I FOIL this, outside, inside, inside, outside. First, outside, inside, last. So the first is 0.5. 0.5 squared is equal to 0.25. First, outsides. Outsides, we have negative 2x squared. So it's going to be a positive 4x squared. Inside, we have 0.5 times negative 2x, which is going to be just negative x. And last is the exact same equation, 0.5 times negative 2x. So once again, negative x. All of this is over our x's again, but I'm just going to simplify. We have x times x, so that's just 2x. Okay, so let's simplify this even more. I could take the 2x and I can bring it over on the same side as the k. So I can have 2xk is equal to, and I can arrange this in a format you guys are probably more familiar with seeing. Real quick, 4x squared. I'm going to combine this at the two x's, so I'm going to get 2x, and then I'm going to have my one with no x, which is plus 0.25. Alright, so far this is the equation, but it's not quite ready. I need it all to be equal to 0. First thing I'm going to do is k, you got to remember, k way back up here was equal to 0.090. So k times 2, if we just times those two numbers together, go ahead and do that. 2 times 0.09 is equal to 0.18. So this is actually 0.18x. Alright, we can just cross this out. You guys with me so far? Let's go ahead and bring this over to this side. So we'll have 0 on this side. That's going to be equal to 4x squared minus 2.18x. You can just see how I did that because as we bring it over, it's going to become a negative, and negatives add. We already have negative 2, so negative 2.18. And we're going to plus 0.25. Well, now it's in a nice, easy to recognize form. This is the form that we use when we use the quadratic equation. So I just went through and did the whole quadratic equation already. Negative b plus or minus the square root of b squared times 4ac all over 2a. So when I got that, I got two results. I got a possible of 0.38, or it could be 0.16. Either or. So let's try and figure out which one it's going to be here. Well, if I take and look at 0.38, if I plug that back into what I had down here, way down here, if you look, it could work out for the two x's. But if I look at this, plug in 0.38 into this equation, and first thing that's going to happen is I'm going to times it by 2, so that's going to be like 0.7 something, and I'm minusing it from 0.5. That's going to give me a negative number. And you can't have negative numbers when you're dealing with matter. It doesn't happen. There's no such thing as negative number, negative matter. So it can't be that. That is not a possibility. So it has to be the other choice. It has to be this. 0.16. So I can take that for X and I can plug it back into my original equations way down here for E. So for H2O, X is just X, so 0.16 molar. Same thing, 0.16 molar for the Cl2O. For this one, it's a little trickier. I got to plug 0.16 in there. So 0.16 times -2 is equal to 0.5 minus 0.32. All I did is plug the x in and times it by the -2. And going down in through that, I get that the answer is equal to 0.18 molar. Does my answer make sense? I have a 0.16, 0.16, and 0.18. My answers do make sense because those are all less than what I originally started with. And it's all going to become products, and reactants. Or reactant, product. So I have a good answer. I think I'm right. It should all be awesome. So hopefully you learn exactly how to use the ice tables in order to figure out equilibrium concentrations.